The first thing I want to talk to you about is our daily commute, transportation. How do we get from A to B on a daily basis? So we have a few options. Number one, we take public transport. We purchase a ticket, jump on a bus, train, tram, whatever. We get from A to B easily. The problem is, well, we don't have to worry about things like fuel, maintenance, anything like that. The problem is we have to share that bus with someone else. Often we don't have really much control over what's going on with the roads. There might be some problems on the road. You have to wait for the next bus, etc., etc. So to upgrade on that, we rent a car. So you choose a model, you choose a pickup spot. There are challenges again. You have to worry about fuel in this instance, but you have more security, for example. Oh, privacy, not security. You have more privacy. You choose when to leave. You choose which road to take. You have more control. The third option is you can go ahead and buy a car. Of course, rent a car is obviously more expensive than the first option. So the third option is to buy yourself a car. Now, your initial investment is quite large. You have to pay for the car. You have recurring costs in fuel, maintenance, insurance, everything else. But you get to choose where you go, how you go. You get to choose if you want to upgrade that car to perform better. You get to choose when to change it completely. So all of these things remind me of LLMs in answers. They follow the same spectrum, basically. Like you have cloud APIs that behave like public transport. You take it when you need it, you go from A to B, you do your job, and that's it. After that, you have things like managed models where you spin up in some private, in some rented GPU servers. Again, you have some control, but not all the control. And then in the end, you can run large language models locally, which would equal to buying your own car. So just like travel, your LLM choices really depend on how much you emphasize control, privacy, and probably that upfront investment, which is very important. That's the journey we're going to take today. We have 6 different sections. We'll talk about why is hosting such an important question when deciding how to run your next AI project. We will look at the trade-offs between different options. We'll talk about some geeky stuff and mention, I promise it's not going to be too much, maybe one slide about high-level architecture. We'll show you some demo, and in the end, we'll give you enough information so you can at least have an attempt at making a decision for your own. Of course, we're there to help you, but hopefully you'll be able to make a decision on what you want to do for your next big project. So the first thing we're going to talk about is the motivation. Why did I decide to talk about this? Well, first of all, Ermin told me to talk about this, so I didn't really have much option there. But I saw this quote from KPMG Gen AI survey, which says that 76% of large company executives, they're naming external AI data exposure as their #1 worry. And we saw just earlier when Ermin asked the question that also some of you are very worried about that. So we'll try to figure out what can be done in that sense. Forecasting your spending, that's another motivation. Token metered usage can skyrocket very easily. So we want to see if we can actually do something about that. Also, do we really have to choose between speed and control? Like, is there a way to have both? We'll try to tackle that as well. And finally, I mentioned LLM hosting options in my introduction when I spoke about transportation. Now, that was very simplified. You know, there are so many other options to talk about. So we'll try to cover that as well. Now, this is the slide that I was very reluctant to put on because it talks about money. maybe I'll just stand here so you don't see it fully. You can't really call me out on it. But yeah, I wanted to put this here. I thought it would be interesting to see approximate cost of using some cloud APIs like GPT versus some private cloud on one of the on AWS in this instance, or self-hosting. This is a very, very, very rough estimate. There are so many factors to take into consideration, and I'm more than happy to help you to do your own estimation to compare the three or even more options. So this is just to have something in our mind when we're talking about these different options. So as we can see, for Cloud API, I thought I'll just compare OpenAI's GPT-4 Turbo 128K. It costs about $20 per 1 million tokens. It's $10 for the, I think it's $10 for prompt and $30 for sample answer. So it gets to $20 per 1 million tokens approximately. It's a classic pay-as-you-go model. It can get out of the hand, as I just said, very quickly if you don't pay attention. The private cloud, I did a very small test with Llama 3, 8 billion parameters on AWS. It was using 4 Tesla T4 GPUs. The cost per 1 million token got down to about $18 or so, but this is full utilization. So just to give you an estimate, it really depends on how utilized your models are. Less utilized, you'll pay higher price. More you utilize it, it's going to be cheaper for you. Self-hosting is probably the hardest to calculate. So this is really rough estimate. I just thought I'll research how much would like 2 NVIDIA A100 GPUs on some mid-range server would cost. On 30% utilization, you're looking at approximately between $1 and $2 per 1 million tokens. That sounds fantastic. And as your utilization goes up, your cost will go down. And we'll talk about this a bit more, but just wanted to give you some sort of rough estimate of what you're looking at. Of course, I think the next slide, before we move on, I just mentioned AWS. I tested AWS, but these are just, feel free to take a picture. These are just some other GPU cloud hosting platforms that you can use. Some of them are really cool, very cheap. Well, not very cheap, cheaper. Some of them are very expensive, very complicated to use. So yeah, just feel free to play, test it on your own and see how they go. So hosting options. I just said, like, my first analogy was very simplified, only 3 options. There's much more, so we'll use different analogy. We'll use hosting a dinner party or hosting a company corporate event analogy. So if we expand that, we have so many different options to do. We can order takeout, sorry, from the restaurant. So you don't do any work, you just order everything and it's all covered. Then we can have our own cafeteria, but it's run by an external company. We can have private chef. They bring their own equipment, but they're using our own stove. You can rent a commercial kitchen and then work there. You can buy prepared ingredients. You can prepare everything for yourself in your house. And then you can organize a dinner somewhere at a remote location, and then you have to have some sort of a camping stove or something. So as we can see, there are so many options, and absolutely the same goes for hosting LLMs. Don't worry about this table. I'm not going to go through the whole thing in details. Just glance at it. The important thing is there is a pattern if you look at the models. So ignore this thing. Just look at the model names here and what they do. So there's Cloud API, there's fully managed LLM in Cloud Tenant, all the way down to edge or local device. So there is an interesting pattern, or actually there are 3 different patterns that we can see here. Number 1, as we move down, we are getting more control ourselves. Control in the sense of infrastructure, control in the sense of compliance, security, privacy, everything. Number 2, our CapEx or capital expenditure, as we move down, it goes up. So for options 1 to 3, it's probably close to 0 because you're renting everything. Number 4 requires some engineering, so you do need to invest some money there. And then 6 and 7, it more or less means writing a big check and getting the infrastructure for yourself. At the same time, as we move down, our operational expenditure, or OPEX, it's lowering. So at the top, you pay per token. So it means that more you use it, the more you pay for it. At the bottom, you're running the equipment you bought. There's expenditure for power, cooling, expertise, but per token fees almost disappear. So why is this important at all? Like, it will give you a clear picture of where your next AI project should be. I'd say that most of the startups and POCs, they live in number 1 or number 2. Actually, most of the companies would start at number 1 or number 2. You'll just grab an API and you'll build something on it, and that's it. More your workload matures, you'll move towards the bottom. Or if one day your security officer comes in and says, okay, hang on, what you're doing with that API is not good. We have GDPR, we have HIPAA, you have to worry about those things. So then you start thinking about 5, 6, or even 7 in that instance. So there's no universal right choice. It's only what aligns with your priorities, basically. So let's bring this home. Picture 2 product teams, Team A and Team B. They're from the same company, they have same goal, they have same kickoff date. Team A, they decide to use public LLM API. They have a kickoff on Monday. By Friday, they already have a prototype. And in just a couple of weeks, they can do a press release and they can go in production. So their superpower would be speed and efficiency. Team B, on the other hand, they decide to build a private cluster. Obviously, their journey is much longer. They have to navigate procurement. They have to build the whole thing, the infrastructure. They have to train, retrain. But after a few months, they do release as well. Their inference costs are predictable and minimized, and that's their win. So there's the main question is who won here? I think they both did, but just on different scoreboards, right? So the Team A dominated speed to market scoreboard, while the Team B conquered the long-term efficiency scoreboard, or security scoreboard as well. So their victories are fundamentally different, but it's just choosing between rental car and owning your own car. There are some trade-offs that you have to take. I think your hosting decision basically will really critically shape your innovation pace, your cost structure, your ability to earn and keep your customers as well. So I think it's always important to choose based on your definition of winning. I'll finish this section with simple 6 drivers table that I think is very important to have. Like, there might be some others to consider as well, but I thought these are the most important ones. So the reality is every company prioritize these things completely differently. So you're racing to launch something, speed is your lead actor. You are worried about sensitive data, data sovereignty, that's your driver. You're on very tight budget, we have cost profile. You're going to ride based on that. So your hosting choice is not about losing. It's about aligning with what matters most at the time. The key is to match your strengths to your KPIs, basically, and to match your infrastructure to your current priorities. So now comes the geeky part, and I promise I'm not going to take too much time on this. This is somewhat of a unified LLM architecture blueprint. This is not really, I did this with the help of ChatGPT, to be honest. We talked about it. We fought. In the end, I won. And we came up with this sort of like 6, 5, 7 layers that are very important when we talk about LLMs. Now, It doesn't matter whether it's in cloud or it's on premises. The whole thing looks the same. The only difference is that when you're using API in cloud, you only see the experience layer. You don't know what's under the hood. And on-prem, you can see all the other layers. So just very quickly, on the top, you have that experience layer that I just talked about, a web chat, a Teams app, or something. Everything below is there just to make sure that this first experience layer is fast, it's accurate, and it's trustworthy. After that, you have access control layer, very simple. You want to know who accessed, when they accessed, what they, well, you can't know what, but if you know who and when, you can find out what. After that, you have model serving layer. They call it the brain. It's like a dispatcher for taxis. It knows exactly which GPUs or which taxis are free to send them to customers, etc. After that, you have the compute layer, which is basically hardware muscle. It's just picture a huge server rack with GPU servers and stuff like that. And then data layer, that's the heart. Like that's where you basically your company documents, your databases, your logs, everything you want to feed the model, that's where it lives. Now we have these two other, I call them operational layers. One is DevOps, MLOps pipelines, very simple. We know what they do. And then you have observability and governance. Obviously, it's like a control tower. So you know exactly what's going on with other layers. So even on-prem, LLM is just like another tiered enterprise app. So meaning that skills, tools, governance, all the patterns that you already use for other applications, they apply here as well. Now, enough with technical geeky stuff. Let's see how we can help you to make a decision. What you can see here is very similar to the questionnaire that we run in our client workshops as well. Of course, it largely depends on client needs. It depends on their wishes, but essentially, these are very few important questions that you have to ask before making a decision. Number one, and probably the most important question is, are we talking about sensitive data? If it's GDPR or HIPAA regulated, your choices are somewhat limited. You're probably going to go and say, okay, I have to choose between on-prem infra or some rented infra or something like that. Once you get that question out of the hand, I think latency is the next one that should be important. If latency is something that we can live with, or maybe we can utilize some of the hybrid model, or maybe you can still go on-prem. Everything after that, if your data is not sensitive, the whole bunch of other questions open up, and they're all important and influential. Like, how important is the customization? Do we have skills and budget? What about elasticity? What about time to market? All of these things, depending on how you answer these questions, they will lead you to one of these. Again, this is simplified, only 3 solutions, but as we saw, there are many more solutions that you can actually do. So this way, we'll make sure that we make the right decision. So let's just quickly see a real case example. So use case 1. We have a chatbot on some web shop. Basically, it's Black Friday. Thousands of people are just pinging and asking, oh, is this in stock? Or do you have this in blue? When will this arrive, etc. So users want an answer right away. If they don't get it, they're just going to run away. Only the big public APIs can spin up thousands of GPUs on demand during Black Friday and then just turn them off once that's done. So your choice is most probably going to be public LLM API. Then we have let's say a burger chain. They have 10,000 outlets all over the country. They store emails and faxes on their weekly counts. So AI only works hard on 2 or 3 days. Buying hardware to sit idle would be crazy, right? You only need it for a couple of days. So instead, we just book a cloud GPU cluster for 48 hours. We run our stuff, crunch the documents, shut it off, and pay just the friction of the time. Makes sense. The third option, hospital. And I don't think I need to see anything else, just hospital. That's it. They have tons of sensitive data. You don't want to upload to ChatGPT patient data. So your basic option, you have to make sure that everything is kept within the company, within hospital walls. And then, you have full control. You know exactly who accesses what and everything else. So owned infrastructure and private LLM makes the most sense in this instance. So there are 3 different stories and 3 different winners, I'd say. Now, demo. Before we go to demo, I'd like to ask you to scan this real quick and get me some answers. I want to know if you're planning to do some LLM projects over the next 18 months. It can be a simple POC, I don't care. Or it can be something serious, but just scan and let me know. I want to know if you want to do it strictly in cloud on API, or you want to do it on-prem, or you don't, just not sure. You just, maybe this will get you thinking. So I'll just real quick. So we have some answers. That's good. Thank you. Go ahead. Come on. Lana, did you scare? Just checking. Do it. So I'll just, did this work? Yeah, I can put this down for a second. Oh, you can still hear me. Okay. So demo. Actually, let me first, while we're waiting for this, I want to tell you about the demo. We had a very, what? Yeah, I'll start singing. That's my only worry. We have 2 different demos. My idea was actually to have it all in one device and to simply test the difference between using cloud API versus on-prem device, just to check speed and latency. But then I thought, we'll do it slightly different. We will check that. But we got another very interesting device that I want to show you. It's NVIDIA Jetson Orin Nano. It's an extremely cool device. It's like PBC, like this big. It actually sits somewhere there. I can't even see it. That's how small it is. But it gives you such a fantastic power. Like, imagine you have a factory that processes a lot of documents, and it's in the middle of nowhere. Internet is very poor. There's no other connectivity. Elon Musk does not provide any Starlink. So you're stuck. You don't know what to do. You get a few of these things. You install simple LLM on it, whatever model you want to do. Well, obviously it has to be open source if you don't want to pay for it. And you have fully functional GPT that runs for like $300-400 of these things. And I'll show you how it works and what we do. So this is a good sign. Thank you. I'll just exit this now. Participants, you don't have to worry anymore. So the first one, actually, let me just quickly duplicate my display so it's easier to okay. So hopefully this is still shared for the guys online. Okay, thank you. So this device is a laptop. Errol knows all about it. This is a laptop that we run EVA. It's fairly powerful. It has ATX 550 NVIDIA card. Well, it's more powerful than laptops that we use for now, our business need. It's not super powerful laptop. It's okay. It will serve us to show the difference in speed or latency between OpenAI and some local stuff. So locally, here, locally, we have Olama. We have simple Olama installation here. It's running on this laptop, and we pulled few models in here. At the same time, I have this script, Python script, very simple one. It's going to go It will take my, I don't know if you can see it. Do I have to enlarge? But really good. It connects to OpenAI that I set up at my in my Azure subscription, and it will compare it to the local host, to local Ollama model. So the first thing I want to do is I just want to make sure that my Ollama is actually running, and it is. Let's minimize this. So let's just refresh. So okay, that's the standard port for Ollama. It's running. That's good. Now we have to go to PowerShell. That's good. And now I'll just run this. Actually, I first have to find where my, oh, there it is. Now I need this one. So I'm just running the environment within this script, and it will allow me to don't have enough space here. So now we can run the script. It's just called, so Python, I think it's called bench.py. First, it will warm up the local GPU, although this warm up thing does not really work well. It should warm up the local GPU so it gives you better results, but it doesn't do the great job. I think the best is when I run it first time, and then I run it the second time, it gives me slightly better results. But let's see. Of course, again, this is just a laptop. So we're not talking about some powerful server GPU. This is very, very basic as it comes. Still, the difference is not huge, as you can see. It does lag. I forgot to show you real quick. There is a prompt. So there are 3 short prompts, and there are 3 longer prompts. So just to test all 6. And as you can see, our laptop won in 1 category only. Normally wins in 2, sometimes 3. But as I said, this is just a plain laptop, and it's still fairly comparable for some basic stuff, for something where latency is not hugely critical, like what I mentioned before, when we talk about some remote sites where we just want to crunch some documents, get some numbers. Latency is not that important. You can use this very easily, and it will. Yeah, go ahead. Oh yeah, sorry, I did not say that. I think for the local one, it's Tiny Llama. I think it's somewhere in the. Oh no, just close it. Doesn't matter. So you specify here in the actual code. Here it's Tiny Llama. Of course, if I was to use some larger model, this is small. I think it's 1 billion parameters. If you use some larger model, it's going to be very slow, obviously. But even this Tiny Llama, it's one of the funniest models that I've ever seen. I'll show you why later in the second demo. It's very cool. I love it. Maybe because it's called Tiny. But yeah, and another thing is this thing generates actually the results HTML, and this is what I wanted to show you. Yes, the cloud API wins most of the categories, but there's a column, the third one, the cost. We don't have a column for local cost because it costs nothing. And this is only, it's nothing. Yeah, it's 0.000 whatever, but this was just 6 different prompts. It's nothing. So imagine this cost will always go up when you use OpenAI. And that's the biggest benefit of running it locally, of course. So this was the first, just a simple demo showing. Of course, if you want to test different models, you just pull it with Ollama, and then you just change the little thing in the script, and that's it. The second one is this little thing. So Jetson Orin Nano, 8 gigabit. It's fairly cheap. It's PBC. There's nothing on it. It runs Ubuntu. You can upgrade it just like you would any other Linux server. And what I wanted to show here, first of all, let's see if Ollama is running here. Again, I'm using Ollama here as well, but as Docker container. And I will have two different containers. One will be for Ollama. The other one would be for Open Web AI or something like that it's called. You guys probably know much more about it than myself. So let's just test localhost. So Ollama is running. That's good. But let's see if should be 8080. And this thing is running as well. That's beautiful. So again, here I have, I don't know if I need to zoom in a little bit. Okay, so it's, as you can see, it reminds me of ChatGPT. It's very similar interface. It pulls any models that you have in your Ollama server. So right here, I have TinyLlama, I have PHI-3, I have DeepSeek, only those three, but you can load whatever models you have. You can even add models through here. You just have to know the exact name. You go to ollama.com, pull the model name, just paste it here, and it will download the model in the backend for you. It's very easy. And why I said TinyLlama is funny, when you say hello, normally you expect an answer, hi, how can I help you? No. TinyLlama has different approach. So it will, most of the time, it will tell you a story. Oh, this was short. Normally it tells you a huge story. Like last time, let me tell you a story about Steven. And it just goes on about this funny story about cat named Steven or something like that. It's a very funny model. So this is very short, actually. But yeah, one I want to show you is the DeepSeek one as well. Actually, let's just start a new chat. And you probably use DeepSeek online already. And we don't like to use it too much with sensitive data. We don't know where it goes, of course. So running it here and testing it here is very nice. So if I just say, tell me a joke, just a simple one. What I love about DeepSeek, and they have this online as well, is that thinking part where you can expand and you can see how it thinks. And it's not just how it thinks. What's very interesting, this was a very short, so what's very interesting is that it behaves like human. It's like, oh, the user is asking me to design a Python game, snakes, whatever. And he goes, okay, I should try this. Oh, maybe he thinks that I should do this. I'll give him two options. It's like arguing with itself. And that's what I love about it. It's like really interesting. I know that ChatGPT now started giving you that thinking thing below, but this one is much cooler. I didn't say that. So yeah, this is, as I said, it's running on something like this, literally. And you can imagine, you can customize, you can do whatever you want with these models. Any of these that are open source, you can do customizations. You can prepare it for the usage. It can work with your documents, whatever you want. So it's ideal for remote locations. It costs close to nothing. You don't have to worry about internet. You don't have to worry about running costs, because even the power is very low on this one. So I think that's it for the demo. I just have one quick last. Let me just change my display so you don't see my notes. You don't think I know this from my top of my head. There you go. Where are we at? So here, probably sharing the wrong screen. Yes, of course. Hey, come on. Where? I don't want to display settings. I just want to change. Yeah, I'll create a ticket. Someone will help you. Hopefully that's the right one. So key takeaways. I think oh, there you go. If you remember nothing from today's session, and you will remember everything, I'll ask questions later. These 4 truths would actually keep your AI roadmap off the front page of the TechCrunch, hopefully, for all reasons. Number 1, prototype in the cloud. I think cloud APIs are like new whiteboard. Like you spin it up, you test, you don't like it, you kill it. You like it, you push it to production. So it's fantastic. Always use that for prototyping, for POCs, for small, quick projects and everything else. Number 2, the iron triangle: latency, privacy, elasticity. It's very similar to like how the developers treat scope, time, and money, cost. So you can't get all 3 green. You get 2, but it will help you to actually recognize when one of the 3 will go red. That's why it's very important. Number 3, private doesn't always mean on-prem. And we saw that. There are so many other options that you can do. You don't have to just pay a huge check and buy the hardware. Number 4 is industrialize your choices. We showed you the flowchart. It can be very useful. I think any product owner can answer those simple 5, 6, 7 questions and can have really good idea of where they want their next AI project to live. So it's very important to be ready for your first sprint. And that's why that last thing is very important. That's all from me. Thank you very much.